All right, you are welcome to today's lectures, and this subject we want to treat now is mathematics. I will continue from indices and what? Logarithm. Indices and what? Logarithm. We've explained, we defined indices, stated the laws of indices, not just stating the laws, we improved the what? The laws of indices. How many of them? 6 or 7? 6 of them, right? Now, today we want to go into what? Logarithm. We want to go into what? Logarithm. So what is logarithm? What is logarithm? So whenever you hear the term logarithm, what comes to your mind? Can someone here define logarithm for me? Can someone here define logarithm for me? Can you? Can you? Define logarithm for me? Can you? Explain. Let me hear what you have to say.
I don't know. I don't know.
Did you do logarithm in your school? And they don't define logarithm. Okay, you forgotten. You did it in your school? Huh? And they did not define it. So define it now. Oh, yeah? Huh? Base did what? Is what? Is a logarithm. All right, it's okay. It's okay. Now let's take a definition, then I will explain. Okay? I wanted to take a definition, then I will explain. Now, the logarithm of a number. The logarithm of a number. The logarithm of a number to a particular base. The logarithm of a number to a particular base is the power or index. Remember I told you that power is index, right? Is the power or index to which the base must be raised to be equal to that number. The logarithm of a number to a particular base is the power or index to which the base must be raised to do what? To be equal to what? That number. This is the standard definition of what? Logarithm. So anywhere you go, they ask you what is logarithm. Just say that logarithm of a number to a particular base, right, is a power or index to which the base must be raised to be equal to that number. So let's symbolize this number and bring it to mathematically. Let the number in question be, let's fix what is it called again? Let's fix alphabet. Am I getting to that number so that we can make it, bring it mathematically and get to the formula, and you appreciate it. I just told you, you just put down grammar. So let's put it what? Mathematically, okay? So let the number be what? Let the number be x. Oh no, so let the number be a. okay? Let number be A. Capital what? Capital what? A. Let number be A. Then let the base be y. Let the base be y, small y. Let number be what? Capital A. Let the base be what? Y. Now look up. Logarithm of this A. Logarithm of this A is a number to which this base of A must be raised. Is number, logarithm of this number A is the number to which this base must be raised to be what? Equal to what? That number. What it means is this. If you want to say logarithm of A to base Y, what will you do? Log of what? A, right? To base what? True or false? True or false? True or false? True. If you want to say log of A to base Y, you write log to base Y, then capital what? A. So what is logarithm of this A? What is logarithm of A to base Y? Is number to which this Y is the what they define there again? So is the power, not the number. Sorry, thank you. Is the power to which this Y must be what? Raised to be equal to what? The number. Now, look at this thing now. Log A to base Y. So what number do you think we can, if you let's assume now we raise this Y now to be, if this thing gives you something like Z now, let's assume that log of A to base Y gives you what? Z. Now what it implies is that A is equal to what? Y raised to power what? Z. Am I communicating? If we have log A raised to power Y, log A to base Y is equal to Z. What it implies is that now, watch now. This Y has been raised to what? Z. Hello? This Y has been raised to what? Z. And Y raised to power Z is A. Logarithm of a number is the power. Logarithm of a number is, can you see the board? You cannot. Logarithm of a number is the power to which the base must be raised to be equal to what? That what? Number. Number equation is what? A. So logarithm of, if A is equal to Y raised to power Z, so logarithm of A is now equal to what? To base Y is what? Z. Is Z not the power to which this Y must be raised to give you A? If Y is raised to Z, it will give you what? A. If Y is raised to Z, it will give you what? A. So that means logarithm of A to base Y is what? Z. This is the power. Logarithm of a number is the power to which the base, logarithm of a number to a particular base is the power to which that base must be raised to give that number. In a nutshell, you can put down, let's fix this A in that, A, Z, and Y in that definition. Watch out. The logarithm of A Logarithm of a to base y. Logarithm of a to base y is what? Logarithm of a to base y is z, because y must be raised to what? Z, to give you what? A. Logarithm of a to base y is z, because y must be raised to what? Z, to give you what? A. Logarithm of a to base y is what? Z, because y must be raised to what? Z, to give you what? A. That's what I put here. That means if you remove this logarithm, this thing is something as what? This. Now, if you find the logarithm of, remember, don't worry, by the time I go to the rule of logarithm, I want to give some one or two physical examples of numbers that will make you understand this thing. Let me get something. Let's look at this. Before I even start solving questions, did you understand this thing? Did you? Are you sure? Now, logarithm of a to base y is the index of power z. Hello? Logarithm of a to base y is the index of power z, to which y, which is the base, must be raised to give what? A. This is what we have here. Now, I want to use number now. I stated it grammatically, use symbols to state it. Now let me now use what? Number, okay? This base must not be 10. Oh. Hello? Are we together? This base must not be what? 10. It can be any what? It mustn't be 10. It can be base 2, it can be base 3. It mustn't be what? 10. But if it is in base 10, it is called common logarithm. If this is in base what? 10, it is called what? Common logarithm. It must not be 10, but if it is in base 10, it is called what? Common logarithm. And it is the common logarithm that you use what? 4-figure table to do what? To do what? To check. Am I communicating? Is this common logarithm that you use 4-figure table to do what? Check. We'll still learn how to, please, in your next mathematics class, come with 4-figure what? Table. Okay? Okay? Do you have it? You have it? You have it? Hey! If you go look for it, look for 4-figure table. You must look for it. In our next class, we would have done it today, but I want to get it so that you do it yourself. You know how to use it, right? So you think we should not no need to do it, or should we do it? So if you want us to do it, get your 4-figure table. Look for where you get it. Don't ask for your friend, buy another one, let it be at home, no problem. It's not expensive. Is it expensive? Or if you can even come with your mathematics textbook, it's at the back of it, true of us. But all I know that you must come with what? 4-figure table in our next class, in our next mathematics what? Class. But let me give you an instance. If we have something like this, log 10 log 100 to base 10. What's the answer? 10. What's the answer? Log 100 to base 10 is what? What's the answer? It's simple. You must not punch your calculator or use forgettable to solve this type of log. This one now is easy. Simply say, go back to the definition of what? Logarithm, right? It says that logarithm of a number is the power to which the base must be raised to be equal to what? That number. So logarithm of 100 to base 10. Let's look up. Logarithm of 100 to base 10 is the number to which this 10 must be raised. Is the power to which this 10 must be raised to be equal to 100. So what power must you raise this 10 to be equal to 100? What power must this 10, which is the base, be raised to be equal to 100? 2. Logarithm of 100 to base 10 is what? 2. Because if you do, watch out, if you do 100 is what? 3 raised to the power what? 2. It's not true. It's not true. It's not true. So 100 is 3 raised to the power 2. So if you raise 10 to power 2. So this index now, this power, this 2 now is the power to which you raise 10 for it to be equal to what? 100. Now check, do log to base 10, log 1000 to base 10 is what? Log 1000 to base 10 is what? Three. Good. Log 1000 to base 10 is what? 3. I agree with you. Now, let me now know those that think. What of log 0.001 to base 10? What's the answer? I'm waiting to know. Huh? 2. Log 0.0001 to base 10 is 2. Look at that again. You know here? Look at that again. Minus 3. He said minus 3. Let's see whether it's true. Logarithm of a number is the power to which the base must be raised, is in the power to which the base must be raised to be equal to that number. Alright, let's raise 10 to the power of minus 3 and see whether we can get this. Let's raise 10 to the power of minus 3. 3 raised to the power of minus 3. Check whether it is equal to 0.01. Is it equal to 0.01? Yes. So log 0.01 to base 10 is what? Minus 3. Is it clear? It's shocking. Math is sweet if you understand it. Follow the rule on Abaya. Hello? Just follow the rules on Abaya. You're going to Please, if you're putting your phone there, please put it off, please, so it doesn't distract us. If you're putting your phone there, put it off so it doesn't distract us or silence, okay? But you cannot stay here to read, please. Just have patience, after you can come. All right, thank you. All right, let's continue. Now, this is what, so now let's look at this one. Let me look for example here. Now, what about this one? Let me change the base now. What about log 32 to base 2? All right, log 32 to base 2 is what? Oh yeah. $16. He says 16. Who else? Fast. He says 16. Who else? First, what should be the first thing that comes to your mind? What should be the first thing that should come to your mind?
What you do? How do I say it? Like what you did that to how many times that base that is how many times you are going to multiply to get it?
So how many times?
16.
So you multiply it by into 16 times. Are you sure what they're saying?
2 times up to 16.
Into 16 times. You know where? Check well. You must give 2 times 2 into 16 times. Do you know the number it will give you? Please don't mistake 2 times 16 with 2 times 2 times 2 into 16. That's something I hope you know. Are you aware? Hello, are you aware? 2 times 16 is not something with 2 times 2 times into 16 times. That is something. The same thing, look at 2 times 8 or 2 times 3. It's not the same thing with 2 times 2 times 2 into 3. 2 times 3 is what? 6. But 2 times 2 times 2 is what? 8. Are they the same thing? So, what are you saying? Check well. What's the answer? Good, 5. That means log 32 to base 2 is what? 5. Is it clear? It's 5. Because if you raise 2 to the power of 5, look at the board. If you raise 2 to the power of 5, you get what? 30 what? 2. Do you now know the difference between 2 times 16 and 2 times? You make it 2 times 2 times. You got how many? Do you know the number you get? All right. Now, let me give you another example. Another example. What of log 125 to base 5? Log 125 to base 5. Log 125 to base 5 is what? Eh? 3 is what? Because 5 is point 3 is what? Is it clear? Is it clear? Good. Now, all these things we've been saying here implies that I think I have already written this thing here. Please don't play with these two things. That log a to base y is equal to z. That is if log a, if a is equal to, okay, if log a to base y is equal to z, that means a is equal to y raised to power what? Z. Don't play with this. These numbers, these two things are equivalent. But this one is called the logarithmic form of this number. Logarithmic what? Form. And this one is called the what? Index what? Form. They have the same value. Are we together? The one that has log is called the what? Logarithmic form. While the other one is called the what? Index what? Form. The one that has logarithm is called what? Logarithmic form. While the one that has power is called what? Index form. Now I want to give you an example, something to solve now. Write the following index forms in their logarithmic forms. Write the following index forms in their logarithmic form. Write the following index forms in their what? Logarithmic what? Form. Write the following index form in their what? Logarithmic form. 125 is equal to 5 raised to power 3. Number 1. Write the following index forms in their logarithmic forms. Number 1 says 125 is equal to 5 raised to power 3. Number 2. 81 is equal to 9 raised to power 2. Number 3. 8 is equal to 64 raised to power half. Number 4. 1 is equal to 49 raised to power 0. 1 is equal to 49 raised to power 0. Are they in this number, these things are called, are they in their logarithmic or index form? So write them in their what? Write each of them in their what? Logarithmic form. I give you 2 minutes to do that. I give you 2 minutes to do that. After, you have 1 minute to come and solve it on the board. I cancel, go to the board. Pass. Go to the board, pass. Take my card. I solve. Okay, I agree with you that 125 is equal to 5 raised to power 3 is certain as saying, putting it in the logarithmic form is log 125 to base 5 is equal to 3. I agree with you. Go and solve the second one fast. Clean the board entirely, please. Let me see what it is. Ozulu is now, it's not complete. Complete is now. Log 81 to base 9 is equal to what? Clean that equal to before the log. Okay, Zoo. I go and solve. So what did he do? That 8 is equal to 64 raised to power half. So the base is now what? In the log. 64, right? So log 8 to base 64 is now equal to what? Half. I agree with you. Thank you. Oh yeah. Come see, oh yeah, the next one. So So what do you do now? The index form is what? 1 is equal to what? 49 raised to the power was 0. So that 0 on that 0 which is the power of 49. Okay, the 49 which is raised to the power 0 will now become the base in the log, right? So we have log 9, log 1 to base 49 is equal to 0. I agree with you. All right, thank you. Now, next question says, write each of the following logarithmic forms in their index forms. Write each of the following logarithmic forms in their index forms. Write each of the following logarithmic forms in their index forms. All right, number 1 says, log 32 to base 2 is equal to 5. Log 32 to base 2 is equal to 5. Number 2 says, write log, then open a bracket and write 0.001. 0.001, bracket close. That thing should be in base 10. The base is 10. Log to base 10, then write log base 10, then you open a bracket and write 0.001, bracket close. That is log 0.001 to base what? 10 is equal to minus 3. Then the C parts, the third question says, log to base half. Log to base half. Log to base half. Then open a bracket and write 0.125. Bracket closes. Is equal to 3. That is simply put, log 0.125 to base half is equal to what? 3. Then the fourth one says log 256 to base 4 is equal to 4. Log 256 to base 4 is equal to what? 4. Log 256 to base 4 is equal to what? 4. So let this become our assignment 1. Let it be our assignment. Okay, it's okay. Show me you write the following, right? That place you wrote the following should be, make it assignment 1, number 1. But I'm going to call other assignment now. I wanted to solve it as an example here, but no time again. So do it as an assignment, number 1. So that means simply change all these 1, 2, 3 to what? A, B, C, D. Is it clear? So let it be A, B, C under that assignment 1. I don't know if what I said is clear. Now, so you take number 2 assignment I want us to go home and solve. Number 2 assignment I want us to go home and solve. Let me get the question. Take this last assignment. It says without using tables, find the numerical value of, without using table, find the numerical value of log 49 to base 7 plus log 1 over 7 to base 7. Without using table, find the value of log 49 to base 7 plus log 1 over 7 to base 7. Any question? Please solve this assignment. If you truly follow this lecture, you'll be able to get the answers to these questions. In our next class, in our next mathematics class, we will look at it, okay? As usual. Any question? No questions? All right, thank you very much for your attention. God bless you.